Good afternoon, everybody, and welcome to today's EAUC webinar. The title of this webinar is Sustainability in Laboratories, Underlooked but Overtly Necessary. And it will last approximately an hour. It is in the Research Live Framework, and in terms of competency level, it's on the road, and any definition for these competency levels can be found on the EAUC website. Thank you for registering, and thanks also to today's speaker. We have Martin Farley from the University of Edinburgh. My name is Emma, and I'm the Member Events and Communities Officer here at the EAUC. If you do have any specific event, webinar or training requests, I will be happy to talk to you at any time. I also work with our community groups, so as a member of the EAUC, I strongly encourage you to join one of our groups, whether it be a community of practice or a regional group. More information about these and how to join can be found in the member zone on our website. You may have previously attended or heard of exchange webinars. These are continuing, but due to their popularity, we have developed a new range of EAUC webinars. These are for EAUC members only and are an added benefit to your membership. They're a little bit more detailed with clear learning outcomes, more expert speakers, and will allow for more complex topics. They will all last approximately between an hour and a half, sort of depending on the topic. Shortly after the webinar is finished, you will receive a certificate of attendance to place on your personal development file as a record of today's training. So there's just a little bit of housekeeping to go over now. I'm hoping that everybody can hear me well. I have muted you all just to avoid any background noise, and you'll continue to be muted throughout the webinar until there is an opportunity to ask any questions towards the end. If you are having any technical issues at all throughout this webinar, please let me know by either posting on the on-screen chat box, which is just at the bottom right of your screen as you see it now, or failing that, sending me an email to easton, that's E-A-S-T-O-N, at eauc.org.uk. You can see that on the screen right now. Hopefully most of you do have working microphones. Don't worry if not, as you'll still have the opportunity, as I've mentioned previously, to ask any questions at the end. If you don't have a microphone, then you can, of course, use the chat box and send a message either to myself or to the whole group, and I can read it aloud, or maybe even Martin will. We'll see how we go. This webinar is also being recorded and will be uploaded as a resource with all presentations later on today. Please feel free to share these resources with any colleagues or fellow EAUC members, and I will be sending you all an email later on with that link to all the resources. Once the webinar is finished, you will also be sent a short survey for us to gain your feedback. Please take a few minutes to complete the survey, as the results will help us to eventually improve our CPD and events for our members. So that's all from me for now. Thank you again for registering, and I'll now pass you over to Martin.
Thank you for that, Emma. Hello, everyone. Welcome to today's EAUC webinar, Sustainability in Research Laboratories. Today's structure, I'm going to start with a quick background about myself and how my position came to be, because it's quite a semi-unique position. And then I'm going to go into depth a little bit about the issues of lab sustainability, and run through what we've been trying to do here at Edinburgh, and also hopefully give you all some ideas of what else can be done at your institutions. And finally, I'm going to look at how we sort of approach dealing with these issues at a broad level and a specific level. And then I will be open to any questions. So quick background about myself is that I studied biology in Canada. I worked as a lab technician in diabetic retinopathy lab in the US, and I researched cardiac differentiation in the Netherlands. And the latter two labs were particularly wealthy labs. And the reason that I bring this up is that quite often in research we associate wealthy labs with being the most productive, the ones that give the most research, that produce the most papers. But I couldn't help but notice during my times that they were laden with inefficiencies. And in my experience, when I went around and spoke to other people, it seemed that this was quite common, and that with research being the ultimate goal, quite often things went wayward in terms of efficiencies and sustainability, and that it was rarely considered. And just to give you a small anecdote, which is just that in my Dutch lab in the Netherlands, we were working with stem cells, and for the first 8 months of my time there, we weren't actually able to turn any stem cells into anything because there was an infection in the stem cells and a contamination. And it turned out the contamination, the source of it was the autoclave, and the autoclave is the piece of equipment usually used to clean equipment and to remove infections. But the technician who had been responsible with who had maintaining this piece of equipment had retired, and because there's not a lot of investment today in technical staff, there was nobody to maintain the autoclave, and it cost the lab over 100,000 euros in trying to deal with this contamination. And it turned out it was quite a simple problem in the end. But it really emphasized to me that these efficiencies can cost labs in terms of money and sustainability. And because there were lots of man hours, there were lots of samples and cells that had to be thrown out because of this contamination. So it's about looking about how we do our research and how we can get the best out of the most out of our research. So I started at the University of Edinburgh as an intern last year. And the position was initially created by obtaining funding through the Scottish Funding Council, as well as SLab and, of course, the University of Edinburgh. SLab, for those who are not familiar, is an organization, UK-based, that really focuses on sustainable research labs. And actually, I'll talk about them more later for now. But basically, these three groups came together and created this internship, and due to the initial success of the internship, we were able to turn it into a full-time position. And I work under the Social Responsibility and Sustainability Department, SRS department here, which has actually just been launched. And so what does this position actually entail? The program's facilitator, as it's called, I run the laboratories aspect of the Edinburgh Sustainability Awards. So every year we have a Sustainability Awards, which I'll as well talk about a bit later. But within those awards is a specific research labs component. And I run that component and all the audits associated with it. I also work closely with SLab to help produce materials and guidance for sustainable labs, such as editing the Good Practice Guide, which is a resource of good science examples and sustainable examples. I also try to share those examples within here in the university, because I find that the phrase that we often hear in labs is that people are reinventing the wheel constantly, and I'll probably reuse it during this webinar, just to emphasize that labs are always coming up with their own solutions, but the communications between them can often be disjointed. So sharing good practice examples and really just acting as a facilitator has a lot of power in it. I also give technical advice, and so I advise about the best equipment and also the best methods. That's also good practice. And quite importantly, I try to identify problematic areas, possible solutions, and hopefully implement those solutions. And I put hopefully because as for now, I've been officially in the post for 6 months, and we're starting to get a lot of success. But of course, it's sometimes reliant on funding and other factors. So you'll never be able to do everything you want, but you can definitely start and go in the right direction. So Edinburgh itself, part of the reason that it's crucial for Edinburgh to look at sustainability is because out of the Russell Group, it actually pollutes more CO2 per person. So for the amount of people we have, we are an incredibly inefficient university in terms of sustainability. And if we want to really deal with that problem, we have to start looking at research labs. And so there's quite a few other universities in the US and the UK that have started compiling some information about excuse me, about the energy consumption. And it seems relatively standard that a research lab per square meter will consume at least 3, if not 5 or 6 times more electricity and energy than other academic facilities. And so I've started putting together a very rough, I haven't finalized these numbers, but I believe that within the University of Edinburgh, 65% of our electricity is going to laboratory infrastructure. And again, this I don't have a final number, but I think that represents about 30% of our actual facilities, and it represents about 50 or 45% of our student body. So you can see that if you really want to have an effect on actual energy and electricity consumption, you have to, well, you don't have to, but a large impact area would be research laboratories. And you can see that on the graph on the bottom left, and on the bottom right, it also shows this, but it also shows a breakdown of how that electricity is being consumed. And now when it really emphasizes that the heating, ventilation, and air conditioning, HVAC, are the largest consumers for the most part. Now that little pie graph can be highly variable depending on the type of sciences that are being done, but for the most part, it holds about true. So again, just to emphasize, there's a lot of potential in research laboratories, and now I'm going to go through actually some of the topics that I've been working with and try to give you a little bit more detail and to emphasize things that you can do and why they're worthy of investigation. So the first thing is fume cupboards. Fume cupboards are usually the spaces that researchers will work in, and they have ventilated systems to remove the air that might contain toxic particulates so that the researchers are safe. Sometimes they can be slightly cleaner zones, but for the most part, they're for the safety of the researcher. And they actually are extremely expensive, something that I wasn't aware of when I worked in the lab, and I don't believe a lot of researchers are aware of. And to improve on your fume cupboards, the first thing you can do is to identify low flow hoods at purchasing. And so if you are aware of a new research building that's coming up or about to be built, it would be good to provide the information to estates about low flow cabinets. And to also, if possible, have hoods that can be shut off. A lot of hoods are on 24/7, and sometimes this will be cited for safety reasons, for health and safety. And while health and safety is definitely a concern, I know that there are research labs that function with fume cupboards, highly efficient fume labs that can work just fine, and they shut off their hoods at the end of the day. Sometimes they leave them on for evaporation reactions, but that's it. And so if you're in the situation like Edinburgh, then where we already have several hundred fume cupboards, and some of them are not low flow, and some of them can't be shut off, then you need to look at the possibility of retrofitting. Now, I'm just starting to investigate this, and I've finally gotten permission now to do a ventilation survey. And sort of the approach that I'm going to take with this is that, first of all, we don't even know how many fume cupboards we have. We don't know how many are low flow. We don't know how many have the ability to be turned off. And so the first step into improving this would be to identify those, and then as well give a cost and benefit analysis about how much you would potentially save if you were to retrofit some of them. This would eventually require some contractors to likely come in and to look at your unique system, because it seems that no two buildings are alike in terms of fume cupboards. But the price of a contractor to come in to look at retrofitting is relatively small compared to the possible benefits and in savings. So I mentioned shut the sash and to turn off where possible. If you don't, only shutting the sash alone can save about £1,200 per year per fume cupboard. And if you can imagine in a building with 180 fume cupboards, that's a lot of savings, and it's a good argument to make. Another thing that people don't consider is that when fume cupboards are left open, they pull out the heated air of the rooms. So you're actually sucking out all the air that you've heated to pay, and you're pulling it out and throwing it outside at a high cost. And so your approach on fume cupboards really depends on your institution and what the buildings are like, but it's definitely a worthy area of investigation because there are huge savings possible. There's a load of case studies out there from US and UK universities that have looked at retrofitting their fume cupboards, and the savings are quite often in the hundred thousands with very short payback periods. So if you have some funding, because this as well would require some funding, it's worthy of investigation. Scientific equipment. I currently act as a resource right now to people who are looking into buying more sustainable equipment and more efficient equipment. Quite often, it's not the first thing on people's minds when they're looking at making a purchase. So I've been working with our procurement department about providing a purchasing guide. The small issue there is that I don't want to act as I'm choosing it, well, as if I have any favoritism for any companies. So we're trying to work out ways that we can advocate efficient models without advocating certain companies. Also at the University of Edinburgh, before I arrived, there was a Switch and Save campaign that actually produced a lot of helpful small stickers, which I've been distributing around the labs. One of the issues with scientific equipment is that people are often very afraid to turn it off because labs are often in communal shared spaces. So having a sticker or even just a handwritten note or post-it, some sort of system which indicates when things can be turned on and off is actually quite a powerful little thing, especially for the high energy use machinery such as water baths, which are commonly left on 24/7. And then I have 5 different things here which I want to mention. I want to focus on sharing. So at the university level, a lot of universities have been pushed to put together large asset registries of all their scientific equipment. And that was triggered by the Wakeman report in 2010, I believe. And so a lot of universities have taken slightly different approaches to how they're going to do this. And while it seems that it's great, it does have potential to reduce the amount of purchases you make and avoid buying equipment that's already available. It's not necessarily being used for sharing yet. So I'm going to talk about as well a little bit later how we've come up with ways to share our equipment. But really, it's also about making sure that the equipment that you have is maintained and that it's reused where possible, and if possible, that it's resold. Reselling is a very tricky issue to enter, but there are a couple of organizations that can help with this, such as Lab Merchant or Richmond Scientific. Now, the reason resale is of interest is that even though there's not a lot of equipment that may be sold unless there's a move out from a building, last year at the Roslin Institute here at Edinburgh, they had one piece of kit that was worth, I think when it was purchased new, it was £220,000. And it was a highly specified piece of kit that was ended up needing, well, it wasn't necessary anymore. Something new had been purchased, the science had changed, and nobody on campus could really need it. And it ended up getting thrown away, I believe. But if we could have just sold that one piece of equipment off at half the value, it would have had quite a bit of financial impact, and it would have had a sustainable impact as well. So right now I'm working with the procurement department and their legal team to develop a template and a procedure so that scientists know that if they have a piece of equipment that they deem is still worthy and still in good functioning condition and still adequate for scientific research, that they can use it and that they can resell it if they follow a proper procedure. And finally, it's also about ensuring that things are disposed of correctly, and that they don't get just thrown away, and that the metal, etc., is sent correctly through your waste departments and recycled where possible. Chemical management. Could talk quite a bit about this, but I'll keep it relatively short. It starts with the procurement and the management. So here at Edinburgh, at our chemistry department, we've installed a SciQuest chemistry management system. And full disclosure, SciQuest, we use it at a cost, so we pay for the system, but it really helps our chemistry department organize all the incoming chemicals that arrive, and it helps consolidate orders as well. And this is extremely powerful because research labs are constantly ordering chemicals, often daily, making 30 purchases in 30 days of different chemicals. And quite often there's a high turnover in labs people are purchasing the same chemicals, they'll use a couple of micrograms of something and they'll leave it on the shelf. And then that university ends up paying for the storage and the space for these chemicals. Quite often they need to be stored in vented cabinets and etc. And eventually for their disposal when somebody finds them 15 years later. I know that our chemistry department, when they had done a clear out, they had found chemicals dating back from over 100 years ago. That's a bit of an extreme, but it really emphasizes that it is quite systemic throughout science to purchase chemicals, not use them all. And so if you can advocate sharing of chemicals, it's extremely powerful. And the estimated savings for our chemistry department initially were about £100,000 per year from this installation of the system. And they actually won an SLab award for it. The next system I'll mention quickly is Quartzy from UCL, which has also been installed in their chemistry department. And it's a free system that is really user-friendly, perhaps a bit more than SciQuest, but it really emphasizes the end user. And it helps labs organize their chemicals in a similar way to SciQuest. And I won't go into too much detail about the differences between the systems, but I will say that there is a comparison of different systems out there if you're interested. And you can access that through SLab on the website. And I want to say that it seems from all the success stories that I've seen in installing some of these chemical management systems, it requires a consolidated approach. And that means that you need top-down support. So you need someone senior to mandate it to some extent. But you definitely need bottom-up support. You definitely need the end product to be something that scientists will use. And can't emphasize this enough, how many stories I've sort of heard about systems being installed from one direction or another and not being taken up correctly, and then sort of ad hoc, not really functioning as well as they could. I want to mention green chemistry. So I know that there's actually some green chemistry specialists within the UK. I'm not an expert on this by any means yet, but there are some good resources out there, and probably the best one that I know of is the MIT website. And what this website does is it proposes alternatives to some of the chemicals that you use. So if you're doing particularly the toxic and harmful ones that require large cleanups and can be harmful to researchers, and this can be extremely powerful. It's good because the approach they've taken with this is that they want to evidence these reactions. So within MIT, they actually show what type of alternatives you can use. They give quantities and et cetera, and they give advice about how you can substitute chemicals. And another, perhaps not quite as developed site is subsport.eu. And that as well is trying to look at alternatives, not just actually in chemistry, but also outside of chemistry, sort of alternative chemicals for such as in the arts that you can use for some of the artistic activities that require certain chemicals. And the last thing with chemicals is to ensure, and this is often through awareness and correct management, that disposal is done correctly. And I emphasize this only because during my time in research labs, I couldn't help but notice that it happened in almost every lab that you would just see on the occasion somebody who wasn't trained properly throwing away some highly carcinogenic chemical down the drain. And that is of high concern for health and safety. And so I would just emphasize that that if you're going to start an awareness campaign or talk about chemicals management, that you emphasize correct disposal. I'm going to talk about the building level, because the building level, there's huge potential for savings often at the building level. Research buildings can often be highly complicated buildings, and part of this is due to the air change rates and the ventilation that that occurs within research labs. And so the CIPSE standard today for most research labs is about 6 to 8 air change rates per hour. And what that means is that all the air within a certain space is changed completely 8 times per hour or 6 times per hour. And from what I've gathered, this doesn't seem to actually be based on any evidence. It's more a safe approach. And of course, you never want to take a chance with health and safety. but there are new systems out, and I would probably refer you to somebody from Cambridge, because if I understand correctly, they've actually just installed a new system. But basically, they're quite expensive systems, and they're from a company called Aircuity. But basically, these systems they monitor live toxicity levels in the air, so that the air change rates can react to those toxicity levels. And because they can react and they don't need to be at a consistent 6 to 8 air change rates per hour, they actually can incur huge savings. And the ventilation systems for these research labs are extremely expensive. So depending on how large the building is, there is the potential for savings within the hundreds of thousands. I know there's a quite well-detailed case study and example from UC Irvine in the US. And there's a fellow named Wendell Brazy who came over and gave some talks about that. If anybody's interested in more material about that, I would be happy to provide it. Also, LED and efficient lighting. So we've had a couple of our buildings here look at their lighting systems and replace them with more efficient LED systems. And again, the savings, they depend completely on the size of your building and how much lighting there is, but there's a large amount of potential there. The cold storage management and passive ventilation is quite a nifty little story that we have from here at Edinburgh. Again, from the Rosalind Institute. It's one of our newer buildings here. When they initially designed the building, the architects had not included in the design a space for the freezer rooms. Now, those of you familiar with research facilities will realize that almost every facility requires a large amount of space for cold storage for the freezers and for all the samples that they have. And because this freezer room wasn't thought of until later, they ended up putting the freezer room on the roof. And so I'm just going to take a sip of water. And when they put them on the roof, it actually afforded them an opportunity. The facilities manager recognized that this freezer room, which was going to hold 80 minus 80 freezers, and now it's actually grown to around 90 minus 80 freezers, that they produce a lot of heat. And it's quite typical that they have air conditioning systems in place to cool all this heat that gets produced by these freezers. And so to deal with this, instead of installing air conditioners, because it was on the roof, it allowed him to simply drill some holes in the wall. And he put in some fans and installed a passive ventilation system. And basically now the air conditioners, which are actually still there, because you definitely want to have a backup system in case you have a bizarrely hot summer day, depending where you are. But the air conditioners now only come on for about 20, 25, or 30 days a year. So for the rest of the year, it's completely done through passive ventilation. And the last thing I want to say about the building level changes is that I've seen, just from some examples here at Edinburgh, that it seems that the best time to implement some good practice changes and management changes are initially right when you're changing buildings. Times of change are ideal for this, and as opposed to waiting until you've changed buildings, allowing people to install, and then asking them to change their procedures. And this goes for a whole range of things, whether you're asking them to change the way they store their samples, or you're asking them to walk a little bit further to access their minus 80 freezers, or if you're asking them to use a different type of LED system for their lighting. So really, I would just emphasize that try to combine all your moments of change if possible, as long as it's not too disruptive. So what else has come up is just a pretty broad range of various opportunities that might not fit in a particular category. Here at Edinburgh, I've been able to secure a bit of funding finally for an LED system exchange for microscopes. Very briefly, I'll just say that most microscope systems, they use mercury-containing or halide bulbs, and not only are they sort of toxic to produce and to dispose of, but they release heat, and so for the actual science, when you have something that's heating up the sample, it's not good. You want things to stay cold, and particularly if you're looking at live samples. And also, microscope rooms are quite often heated by air, or cooled by air conditioners, and because they release so much heat. And today now there are LED systems out there for producing the same light, which as far as I can tell, the light is actually of a better quality for the research. There is no heat produced, and so thus no air conditioners if you get enough of them. And most importantly, you can turn them on and off quickly, because the old bulbs needed a 45-minute warm-up time. And what this meant is that bulbs would stay on for 12 hours a day versus an LED system which has a lifespan about 10 times it, but you can turn off instantly. And it's safer as well because you don't have mercury bulbs sitting around where you might have students potentially. So today, well, actually today after this we have a meeting, we're going to start looking into making a case study as well about the advantages of installing LED systems. And full disclosure, I should of course mention that the LED systems, the reason we needed this investment is because they are significantly more expensive, but it's helped that we've had academic support for this. Because the academics recognize that LED systems have more advantages than just sustainability. For those of you who work with research labs, particularly in life science, you might have heard quite a bit of ethidium bromide. Ethidium bromide is commonly used in gels to dye DNA and stain DNA, and because of this property, it can stain your own DNA and has the potential to be, well, debatably carcinogenic. And because of this, when people work with gels, the gels when they run the DNA, the stations that they work with have to be kept sort of separate from other stations. They're quite messy, gloves are required, and all the waste produced often needs to be incinerated. And there are huge amounts of gels being constantly produced in most life sciences labs. So if you can remove ethidium bromide, not only do you remove the toxic component from your lab, you also make the cleanup a lot more affordable and a lot more sustainable. And the argument often for not going for ethidium bromide is that the other stains and dyes out there are not as sensitive. But I just put that little diagram down on the right to emphasize that most of the dyes today are actually more sensitive and actually better than ethidium bromide at staining DNA, such as Gel Red, and some of the others are cyber safe. If you want any examples, feel free to contact me afterwards. Equipment sharing. So I'd mentioned equipment sharing before. Within the University of Edinburgh, and I think we're following the lead from UCL on this, but we've installed a system called Warpit. Now Warpit is sort of, I guess, a gumtree for equipment and for furniture and things like that, that you share for free. So for example, if I have a table or a chair or a centrifuge or an autoclave and I don't want it anymore, I can post it. And then through Warpit, we've developed an only in-house Edinburgh system so that if we post something that only somebody within the University of Edinburgh can actually accept it. And that removes a lot of the liability associated with giving things away, particularly scientific equipment. UCL has had this up and running now for about a year. And if I think I remember my figures, you can access them quite easily by just typing in Warpit and UCL. You can see that I think they've over 55% of this things they've traded on Warpit have been research lab based, and from the first year alone, their savings were I think about 30,000 or 40,000 pounds. So it's about 20,000 pounds potentially in savings in from research equipment that was shared and reused, and that has a knockdown effect not just on sort of sharing of equipment, but also on purchasing and disposal, because it really means you get the most out of the equipment you already have. I also want to mention helium management. Done quite a bit of investigation into this topic. You may or may not have heard, there's various articles about the looming crisis with helium and how our supply is being reduced. The bulk of the stores today in helium seem to be in the US, and there's discussion of those stores being closed and being kept within the US. And there's actually some articles out there debating whether this scare is appropriate or not. But what does seem clear is that the price of helium will significantly increase in the coming 5 to 10 years, whether or not, no matter how the supply is affected. And so BOC is the largest supplier today of helium. If you ask your NMR or your engineering departments, you may have heard that there was a recent increase of, I think, 9% on liquid helium, which is not insignificant. And furthermore, about a year ago, supplies were were limited, allocated, so you could only purchase so much. So right now, anyways, we're working with EAUC to look at a possible solution, because when we initially looked at in-house recycling and purchasing compressor and liquefier, etc., it was too expensive initially. So again, this is something that would require investment. And the BOC opportunity, which I would sort of advocate or push for you to bring to your NMR departments or your physics or engineering departments, or anybody with large magnets really and that are using liquid helium for cooling, I'd suggest that they contact BOC and ask them about the possibility of them offering a system. We're waiting right now for a price tag on such a system, and hopefully we'll be able to obtain funding, because it's actually limiting the research. And when you say it's limiting the research, it has a lot more impact and it catches a lot more ears. And I didn't actually put this on the slide, but I did want to mention that I've been working with our procurement department as well into looking at packaging, particularly in the fact that a lot of scientific materials come with excess packaging. We send back, or we throw away boxes and boxes of styrofoam or polystyrene all the time, and it's not necessary. Often they come with one small little vial in them. And so I'm working now with our procurement department. I think here we're represented by the EAUC for our suppliers contracts. I think it's of course different depending on where you are, but the EAUC notified me that actually a lot of the contracts that they negotiate already have within them agreements that say that the companies will do reduced packaging. It's about following them up and enforcing them. And of course, the last thing about procurement I'll say is that we are also looking at better ways that we can further consolidate our orders. And the chemical management systems, of course, aid in that greatly. So if you have a consolidated chemical management system, it really helps you put together your orders. When I first started, I was trying to think of things that I could do that didn't require funding. And so for those of you that might be looking to have an impact in labs initially and don't necessarily have the funds, I would emphasize these three things. The first thing is inductions. Quite often when you come into a research lab, you are inducted by a postdoc or a PhD who's only concerned with the papers that you are to be working on. And because of this, you never get sort of educated, well, you rarely get educated about how the whole lab works, or about sustainability, or about the more efficient methods that you can do something. And often you learn something in the beginning, you ingrain it, and then you never change it. And so due to this, I decided it would be good to have sort of a formalized induction that emphasized some of the sustainable aspects of the labs and did not compensate, or did not put health and safety into jeopardy at all. And so I'm just going to jump a slide ahead to show you very quickly this one pager that we put together. Basically to really emphasize some of the high impact areas that you can be more sustainable and more efficient in the lab. And really wanted to boil it down to one page, because initially I'd been working with large frameworks and lots of documentation. And I think it can be quite cumbersome, especially for researchers who their prime concern really isn't sustainability. So making it in a format that's quite easily accessible has really helped raising awareness and pushing this in our buildings. So now I have 7 buildings here have agreed to, in some form or another, include this in their induction materials, which is great. And I've actually also used this same document as blown it up to poster size and sent it around. And so far, everyone's seemed quite positive about sharing it and happy to put it up. I want to mention as well exit policies. So I worked with health and safety here, and we've developed an exit policy because research labs are notorious for high turnovers, and when they leave, they often don't clear out their samples, their chemicals, and their freezers. They stay there for 10 years. They become unlabeled. They become a health and safety issue, and then they have to be disposed of in the most often incinerated. And of course, that's not the most sustainable way that we can do things. So I developed really just an easy checklist, one-pager that scientists will be asked to fill out by health and safety officers, hopefully across the whole university by the end of the year. And the idea is to really just force people to take a tally of what they've been purchasing and the mess they've made before they leave. Quickly, I just want to say one other thing on inductions is that it's good to emphasize the students in this as well, because a couple of buildings, they told me that they could do inductions, but they didn't think that inductions for students would be okay because 2 months, the student might be there for 2 months. And the response I got from a chemistry department stores person was, it only takes a day to blow yourself up. So really, every student should have a proper induction in the equipment that they're learning to use and the chemicals, even if they're there for a short term. And finally, sort of the ways that I've been mentioning, I've been trying to raise awareness. And part of that includes making a lab demonstrator guide. So the demonstrators who will be actually working with the students, I've made a guide for them to sort of prompt them on sustainable issues in the lab, which I'm trying to distribute now. And also I've gotten the biology and teaching organizations to agree to allow me to just give a very, very short talk on a couple of sustainability issues at the same time as the health and safety talk. And I think it's important to, if you can, try to merge it with health and safety because it has a bit more of a mandate. The last topic I'm going to talk about is cold storage. And here are some quick examples of how you can really have an impact in cold storage. Save-A-Watt is a small device that you can plug in onto the back of your freezer. It just plugs in, and basically it controls for variations in voltage. And it's been installed now at the cost of I think around $12,500. Purchased over 100 of them at the Roslin Institute, and the payback period will be about 2 to 3 years, and with savings of about $4,000 to $5,000 per year projected. And we know that at King's College they have done some similar work with Save-A-Watt and found that it is also quite beneficial. I've done some energy consumption studies, so I'm going to talk about -80 versus -70 in a second. Also been looking at -40 versus -20. Commonly DNA is stored at -40, but it can be stored at -20, and huge energy savings there. There's standard operating procedures, standardization. So I found that throughout the university, we have quite a disjointed nature at Edinburgh. There are buildings sort of scattered all over. And because of this, our standard operating procedures are not consistent. And there are huge savings here as well. If you have correct defrosts, and so that means that the door can close properly and it's not just leaking out cold air. The freezers are well maintained, the filters are cleaned, and so they're not running harder, or the compressors are not running stronger than they need to. And a huge one is alarms and risk and sample management. Cannot emphasize this enough, how many freezers I've seen that didn't have appropriate or enough sort of alarms. Well, they had alarms, but they didn't have a sort of risk process in place. And when you think about losing whole freezers worth of material, this can be catastrophic to a lab and extremely expensive in terms of finance, man hours, and all, of course, sustainability. And so I've been trying to work with labs and just standardizing the good practice that we already have here. Also, if you can sample management, you ask them to consolidate their samples. It's always very difficult to get researchers to get rid of samples, but we try where we can. And the last thing that we've just set up, quite happy about, is that we've been able to set up a freezer exchange fund, tapping into an energy efficiency fund, which we happen to have at this university that I learned about. And I've set up an application form now because often the barrier for purchasing more energy efficient equipment is that it just costs more. So it actually saves the university a lot of money if you can offer the funds. They can pay for, they can supplement the extra cost of the more energy efficient model, and then the model will often can be twice as efficient, especially with freezers, and can last 5 to 10 years longer sometimes. I want to talk very quickly about this long-term cold storage study that I've just set up and I've been managing now. This study is looking at, I'm going to go into a tiny bit of technical detail. It's a lot of the freezers that we use today are set up -80 centigrade. And the question we had was, why are we doing this? Because if you're familiar with research about 10 or 15 years ago, most freezers were set at -70. And it turns out, from what we can gather, that this has been really industry driven. It's been a marketing technique to say, look, our freezers are more efficient. and they go colder. And it's also supposed to be about your reaction time. So if the power is cut, those 10 degrees are supposed to afford you a lot more time to react to come and save your samples. Studies have shown that those 10 degrees actually consume 25 to 30% more electricity and only afford you about 15 to 20 minutes more in reaction time. So why we have our freezers at -80, we don't know. When we approach scientists on looking at why they do this, they say they need an evidence-based approach if we want them to raise their temperatures to -70. So because of this, we've been able to set up an experiment now in partnership with SLab, BWR, and Eppendorf to set up a 5-year experiment, and hopefully we'll be able to extend it to 10 years, in which we'll have 3 freezers set at -80, -70, and -60, all containing exact replicates of samples. And we're looking for feedback on what type of samples you might want stored in them, or your researchers or your scientific community might want stored. So I'm going to ask, if possible, if you could take that link and distribute it to potentially your contacts within your universities. That would make our study a lot stronger. We're looking at really putting as much as we can within these freezers and really providing the study that nobody has yet done to help solidify why running our freezers at -70 is fine for the samples and saves a lot of money and makes sense. Now, before I end, I just want to quickly talk about implementation, and the approach I think is vital for this, because approaching science labs is very different from approaching well, most other areas. I really emphasize when I approach labs that sustainability is about efficiency. I put the little sustainability model because I know how people view it. I really always bring up efficiency, and I always try to emphasize that good practice in sustainability will equal good science. And really emphasize that at the end of the day, you're just trying to save them more money so that they can do more research. You're trying to make this appealing to them, because quite often sustainability arguments don't pull the same strings that they do with a researcher. And I always emphasize that research remains the focus, that safety is paramount, that you never want to jeopardize a researcher's safety. And to help with that, a technical understanding of some of the things you're asking is fundamental to the improvement. It is, I find, crucial to have a basic understanding of the technical matters to really be sure that you're not jeopardizing safety, and to really understand how you're improving efficiency and why it's not jeopardizing the science either. And so there's 2 large approaches that you can use, or that we've been using it here at Edinburgh. And one is either through the SRS Awards. So we have a yearly sustainable sustainability awards, and within that we have a lab section. Now, the sustainability awards are quite similar to the Green Impact Awards, but we've taken them on and we've changed them a little bit for ourselves. And the changes include our own platform for submitting evidence. So we see the evidence before we go in for the audits, and the audits are conducted by myself, not students, and peer auditors. And that means people who have participated, who have background in science from other buildings, come with me and audit other buildings. And that is, I can't emphasize how strong of a tool that has been in change. Because when you have good practice in another building, if it comes from me, it doesn't have the same impact. But when it comes from another practitioner, from another building, it makes a world of difference, and it stops all the no's or excuses. And importantly, these lab awards, they've provided me access to these labs, so I've been able to really get in there and see during the audits and during the time that I work with them, really identify the issues. And I'll say that it's incredible, despite how disjointed the university is, how few people have actually stepped into more than one lab and really been able to compare. So having access has been extremely powerful. Very quickly, I'll just say that the lab awards have been an evolving process. If you want to know more about how we run it, I suggest you go to our website, but we're going to start introducing bi-yearly audits. We want the evidence so that they can build on the evidence they've submitted last year, so that they don't feel like it's too repetitive. We don't want them to feel like it's a paper or box-ticking exercise. So in that sense, we want them to be able to build on what they've submitted last year. And importantly, there's a final ceremony. and there are awards handed out. And it might seem silly, there's a picture of it there, but it's really nice. It's a great networking opportunity. It brings people together, and people share good practice, and they talk about sustainability issues in labs. And it gives things a zest, and it brings a fun factor to it that sometimes it lacks. And just to say that we've had a bit of success with the awards. The first year before in my internship, there were 4 labs. This year we had 7. We've got 10 signed up for next year. Everybody's been repeating. They're all happy with the process thus far, and we've really gone to them throughout to ask them if they want to change it at all. And we've also seen increased SLab submissions for awards from the University of Edinburgh. And for those not aware, SLab submissions are awards that are on a national scale and actually international now about lab sustainability things. Those are about really innovative things that you think you can see on an international scale, whereas our lab awards are really for in-house local solutions. And very quickly, I'll just say that the SLab Framework is the tool that I use with these awards, and it draws in on all these different things, and there's a slight edited version that'll come out this year, and I assess all these different aspects in the lab, and we've touched on quite a few of them in the topics. And the final thing I'll say is that if you're not able to go with a broad approach in the award system, targeted projects seems to be the way to go. Easy wins might be rare, but you need to target win-wins, and that's to say things that can save money, that improve sustainability, and that often improve research. And hopefully described a couple of those, such as helium, for example. It's always great and, well, crucial to gather academic support, such as the helium, or state support in doing these, because often it'll be states that are actually doing some of the physical changes that are required. It's good to discuss these things openly with colleagues, and of course bring an evidence-based approach. Scientists will always ask for the evidence anytime you ask them to do any change. And finally, I'm going to say that funding is often key. So initially I was trying to find a couple of projects that didn't require funding, and so now I'm starting to learn how to pull out funding. Sometimes if you're in England, you can make actually applications to a catalyst fund through SLab for small sustainable projects. We were able to get some funding from the Scottish Funding Council, as I mentioned, for my position, and really emphasize that if you want to get someone in to start looking at these types of issues in similar role as myself, maybe start with some outside funding, but I believe that it's easy enough to eventually make a case study that the funding for this type of position will save the university far more than they're spending on it. And so really to always make your case based on potential incurred savings. And so that's about it for me. Just about 5 or 6 minutes now, I believe, for questions. Just to say that to re-emphasize, laboratories are great areas to target. There's a huge amount of potential in them. There's a multitude of things you can work with, and just to remember that your approach might have to differ a little bit, but that it's definitely worth it. And finally, I'll just re-emphasize to please spread our cold storage study for our long-term study, because we're just circulating it now, and it would help us a lot. And that's it for me. The SLab conference is in London on the 2nd and 3rd of September if anybody's interested. There's a huge amount of talks. It's really great experience, and I would say if you're interested in this, please go. Thank you very much. If there's any questions now, I'd be happy to take any. Perfect.
Thank you, Martin. I'm sure everybody will agree that was a particularly informative and interesting webinar. We do have some time, a few minutes for questions now, and if anyone did want to stay a little bit longer, then I'm sure that's okay. If not, you can send questions to myself, and I can send them on to Martin. But I think we have Martin Miles from the University of Bristol. He's got a couple of questions.
Yeah. Okay.
Hi, Martin. Can you hear me?
Yeah, you're a bit faint, but I think so.
Okay, right. I'll speak loudly. A couple of quick questions. One was about the Sabre Watt. They've been around for years. Have you actually done some monitoring to see that they actually save?
No, I have not actually gone out with an energy monitor yet. during our long-term cold storage study, we're going to have a month with some freezers to work with freezers alone, and we were actually hoping to include that in our study, though.
Oh, brilliant. Oh, that'd be good to see some of those results from those. The other quick question was really about the sample consolidation. We've done, we've been offering quite a large chunk of money to people to consolidate and rationalize on their freezers. And I think today I've had one freezer kind of retired. So I'm just interested to know whether or not you've had much success in that sort of side of things, especially around the sampling.
No, not really. So sample consolidation is quite difficult. They're extremely defensive and territorial of their samples, but I have found that it seems now the best way I'm going to be able to get in there is by offering them new, more sustainable freezers. So I've been working with our Wellcome Trust here and basically sort of trying to find the most inefficient and oldest running models and target the ones that were already going to be changed, provide some extra funding for them to get the more efficient models, and in that moment of change, then ask them to really go through and get serious about changing their samples. So it's not the cheapest solution, but it's I think the best that we have for now.
Okay, thanks.
Lovely. Okay, is there anybody else? Any other questions going around at the moment? I haven't seen any in the chat box, so if anyone did want to ask any aloud, please unmute yourself now and sort of introduce yourself.
Hi Martin, it's Joanna Chamberlain from the University of Cambridge. I'm really interested in what you were saying about swapping out lights for LEDs in microscopes, and was wondering what sort of, or how you've got about getting engagement from the academics. We have a department, our plant sciences department, who are doing similar things in their plant growth chambers, swapping out the old lights for LEDs, and they're going through a very long process, obviously trialling them to check that their plants still grow properly and it doesn't impact on their research. It's all looking very positive, but we're about 2 years down the line and we still only have one plant growth chamber that's got LEDs in it, and so I'm just interested about how you've gone about getting the academic buy-in to that.
Part of the academic buy-in, I think, is that I haven't actually gone in for growing rooms. I've gone in for microscope rooms, and I think there's already been a fair bit of sort of research done on the advantages for LED systems for microscopes. I actually haven't really encountered that many growing rooms yet that are around here, and actually, it's a good point. Should investigate a bit the type of lightings that we're using here. For microscopes, though, it seems that most academics recognize that the LED systems, at least, are better now. And it was actually an academic-pushed solution. And it was during some of my lab audits that sort of a microscope user mentioned it to me. And I just was able, when I sort of presented to our registrar here some of the projects that we had, it caught his ear and happened to get some funding. So just how it happened.
Okay, thanks.
Do we have any more questions from anybody at this time? Oh, we've got Martin Wells has got one final question. He's wondering, I might just ask it quickly for him now, whether some of your resources are available online.
Yes, so that's one of the projects that we mentioned is sort of updating our website here. So if you go to the University of Edinburgh Labs and Sustainability page for laboratories that I have up there on the contact, there's some now particularly on our long-term cold storage. As a resource, SLab has quite a few documents on there as well for case studies, but I hope to sort of be improving our website as the year progresses and get a lot more up there. If there was anything in specific that you wanted as well, you could just contact me and I could try and find it for him.
Okay, perfect. It might even be that we could, if I could get the link from you later, and then I could link it from the page that will have the recorded webinar and presentation on. That might help.
Sure, yeah.
Perfect. Okay, are there any more questions out there? I know that sometimes it's a little bit difficult to think of them straight away and it might come to you later on. And if it does, please feel free to email myself. As I mentioned earlier, I will be emailing you later, so you can just reply to that email with any questions, and I will obviously pass it on to Martin, so he should be able to get back to you. But if there aren't any questions now, I think we'll end it now. Keep it pretty on time. It's just gone 1 o'clock now, so I'm ready for lunch. I don't know about everybody else, but again, thank you, Martin. That was a brilliant webinar, and thank you everybody for attending, and hopefully see you all on the next webinar.